So I will start with the class. So can any one of you tell me what we had discussed? Preparation of carboxylic acid. And to whom I will be asking the question, they can put down their mask and they can give the answer. Whoever I am asking, not everyone. Okay? Now in that case, when I am talking about the preparation, if I have a toluene, if I want to convert it into benzoic acid, which is that condition I have to provide?
Alkaline condition.
Alkaline condition, that's all. Okay, that's what?
And heat.
And heat, okay. If I take toluene, if I put some potassium hydroxide and if I heat, I will get the benzoic acid. Huh? Don't say that.
Yes, sir, that's it.
No.
Alkaline came in the flow.
Ah.
And we must heat it. Then
Done. KMnO4. Okay. So we have to provide the oxidizing condition. So that's where we have the alkaline KMnO4 which can go for the reaction where toluene can be converted into benzoic acid. So what is happening there? A methyl group will get oxidized to a carboxyl group. Right? Whether I am clear? Now, I have a molecule. You should tell me whether even this molecule can go for the reaction. Whether this one can go for the reaction? No, because one compulsion here is during the reaction, OH group requires presence of hydrogen over here because it will attack that particular carbon. So therefore, if there is no hydrogen to the carbon which is attached to the benzene ring directly, then the reaction will not happen under this condition. Okay? Whether I am clear? So at the same time, if I have ethyl benzene, you got that? If I have ethyl benzene, how to convert? What will be the product? If I take ethyl benzene and if I go with the same condition, alkaline KMnO4. You have to read. Anyone? It will give once again benzoic acid only. Okay, it will give once again benzoic acid only. So you should not have any confusion. Fine? Shall we move to the next one? So next one is once again preparation of carboxylic acid only. That is by using, what is this? It is a nitrile. Since we are talking about organic compound, we can call this one as a nitrile, not as a cyanide. We can call it as a nitrile because all of us we know that when same CN, when it is attached to silver, we will call it as silver cyanide. Okay? Because it is an inorganic element. But when I am talking about R, where R is nothing but alkyl group, which is an organic compound. So therefore, this cyanide we can call it as a nitrile. So that's where I have the alkyl nitrile. So when it will be undergo for acidic condition or basic condition, that is hydrolysis, acid hydrolysis or basic hydrolysis, any one of these two, not both. Or I will make a separate reaction. Say for example, it can be acid hydrolysis or it can be basic hydrolysis. Okay? So that's where we have the two conditions. So one is basic hydrolysis and another one is acid hydrolysis. Okay? So that's where there will be formation of an intermediate. There will be formation of an intermediate which can be called as amine. Which can be called as amine. So to make you understand, I'll be writing a reaction, but you should not write that one in your exam. If you consider these two, which will be positive, which will be negative? If I take Cl, which will be positive, which will be negative? Nitrogen will be negative, no doubt. And carbon will be positive. Right? So if I take water, now it's only for your understanding purpose, don't write these things in your exam. So if I take water, okay, now we have a positive part here and we have a negative part. Okay, so it will go to this carbon and it will come to this nitrogen. So what will happen? We are going to have the RCONH2. Right? So what is happening here? Positive part. It is going to the negative part and negative part is going to the, negative part is going to the positive part and positive part is going to the negative part. So that's where we can remember the reaction. It's only for the remembrance of the reaction. In exam you should not write all these things. Fine? So which is that molecule which is I have written here? Any one of you, both the cases it will give same. Which is that one? It is alkyl amine. Very good. It is nothing but alkyl amine. So here also we are getting the alkyl amine. Now, which on further hydrolysis? Which on further hydrolysis will give respective carboxylic acid. Which on further hydrolysis will give respective carboxylic acid. Now once again, same logic. Here also we have H plus OH minus. Since we are talking about the water, it can be having H plus OH minus. Now in this case, which is positive and which is negative? So naturally carbon will be positive, nitrogen will be negative. So negative, it will take up the positive part and this will go to positive part. OH minus will go here and this one will come here. So that's where RCO, then OH. RCOOH. Okay? Same here also same logic. OH minus will come here, H plus will go here because negative, positive. So therefore RCOOH. That's where we have the carboxylic acid. Okay, that's where we have the carboxylic acid. This is how we can remember the reaction. Don't by heart. Okay, we cannot memorize the reaction. So that's where we have the amines which on further hydrolysis can give rise to a respective carboxylic acid. Now, if I take the second one, since this is carried out under a basic condition, but my point, since this reaction is carried out under basic condition, we can show this one as carboxylate form. We can show this one as carboxylate form. Whether I am clear? Say second one, basic hydrolysis means what? A hydrolysis of a compound under basic condition, alkaline condition. That's where basic hydrolysis. That's what OH minus talks about. So if a reaction is carried out under this condition, all of us we know that carboxylic acid is an acidic functional group and under basic condition it will be in the form of ionic state, carboxylate. So to be more appropriate, I will show it as carboxylate. Now this will be carboxylic acid because it is acidic condition. Now any other product you expect?
Basic ammonia, acidic ammonia.
Very good. Yes, in the basic condition we are going to get ammonia. If you don't write this one, then also you are going to get the marks, don't worry. Since we are in organic chemistry, exact balance in the equation is not required. If you don't write ammonia also, no need to worry. Because we are interested in carboxylic acids, not in ammonia. Okay, but for your this one purpose, when I am talking about basic condition, we are going to get the ammonia, but under acidic condition, whatever ammonia will be there, it will get converted into ammonium. It will get converted into ammonium because since ammonia is a Lewis base, under acidic condition, what will happen? It will donate the electron and it will become NH4 plus ammonium. Okay, so that's where we have the reaction under acidic condition, under basic condition. Any doubts? Right. Please remember in exams, even in board exams, not only in competitive, even in board exams, all the questions will not be straight questions. Some questions it will be asked in such a way that where you have to connect between more than two chapters. You have to have the connectivity. Now the question will be, explain the preparation of carboxylic acid from alkyl halides. Explain the preparation of carboxylic acid from alkyl halides. Sir, this is cheating. In alkyl halide this was not there. Then why you are asking this one? Not me. It can be asked, I am telling you. Now how you are going to connect? That's how you should learn organic chemistry, right? How you are going to connect? Anyone? It's easy. Think and tell me.
Surface reaction, alkyl halide to aldehyde, from aldehyde to carboxylic acid using.
Okay, that can be one of the method, fine. Where alkyl halides can be converted into aldehydes, but still not appropriate one. Very simple one is that. Go for nucleophilic substitution reaction. So where I have got the alkyl halide, treat with hydrogen cyanide or sodium cyanide, whatever it is. So now what will happen? Nucleophilic substitution reaction where X minus will be substituted by Cn minus, or halide will be substituted by nitrile. So we are going to get this molecule and further reactions are same. Any doubts? This is how the question can be asked in your exams. Got my point? Or to be more appropriate, even they can tell, explain or write the reaction involved in the preparation of carboxylic acid using alkyl halide where amides will be the intermediate. Then you have to take this particular reaction only, no other options. So where in the first case, whether you can see, in the first case, whatever alkyl halide is there, I have got the nucleophilic part as halide and I have got the nucleophilic part as nitrile, in this case cyanide. So naturally, this nucleophile will come here, this will be released. Therefore, it is called as nucleophilic substitution reaction, which you have studied in the form of OH minus. In your textbook, in the alkyl halide topic, you have studied SN1, SN2 reaction where they have used OH minus. So here instead of OH minus, I will use nitrile or cyanide group, Cn minus. That's all. Okay? So that's now one step extra. That will be one step extra. So any doubts? Shall we move to the next one then? This is how a reaction can be carried out for the preparation of carboxylic acids. If you don't have any doubts, we will move to next part. Fine. ಹಾಗಾದ್ರೆ next one is that is related to Grignard's reagent. Next one is related to Grignard reagent. But only thing is here whoever is there online, I can't see the questions. If you have any doubts, that will be the problem. Okay. Anyway. So when it comes to next one, that will be preparation of carboxylic acids from or by using Grignard reagent. Okay. So 1 mark question they have asked many times. Write the general formula for Grignard reagent. What you are going to write? Very good. That's where we have the RNGX. That's where we have the RNGX. Where all of us we know that this will be a covalent bond and this will be ionic interaction. That's where we have the RNGX. Carbon metal linkage. One of the rare interaction which can see in the nature. Right? Very often we will not see carbon metal linkage. So this is one of the example where we have the carbon metal linkage. So that's why we have the Grignard reagent. Now, when it comes to Grignard reagent, which is the positive and which is the negative part? Okay, good. Then Mg is positive, or we can tell that even this will be negative. No, this is absolutely correct. So that's where we have the positive and negative part. Now here especially it will be in ionic form. Okay, especially it will be in ionic form. That's where we have the positive part, negative part. Now this Grignard reagent we are going to treat with the carbon dioxide. We are going to treat with the carbon dioxide. Now any one of you can tell me what is the speciality of the carbon dioxide? So what is the speciality of the carbon dioxide? Okay, sp hybridization. Okay, fine. Any other thing? Okay, fine. Okay, very good. That's what I wanted to answer. We know that when I am talking about the carbon dioxide, this is where we have the molecule. If you see the carbon is in its highest oxidation state. Carbon is in its highest oxidation state. That means this carbon can act as an electrophile. This carbon can act as an electrophile. What do you mean by electrophile? Electrophiles are those which can attack the electron-rich region. Electrophiles are those which can attack the electron-rich region. Got my point? So that's where carbon can act as an electrophile now, because it is at highest oxidation state. Why? Because it is attached with the two oxygen, which is an electronegative element. Next to fluorine, oxygen is the one which will be electronegative in nature. So therefore, we have -2 oxidation state for oxygen. So therefore, carbon will be +4. Okay? So if that is the case, in this molecule, in Grignard reagent, which part of the Grignard reagent will be attacked by the carbon dioxide, especially carbon part? Halogen. Okay, alkyl. She is telling alkyl. Any other answer? Okay. He is telling halogen. Any other answer? No answer, sir. We are neutral. So normally not halogens, it will be alkyl. Okay, it will be alkyl. So this particular carbon is going to attack. Now due to that what will happen? R CO, okay, minus MgX. RCO minus MgX. That's what it will happen. Why? Because this carbon has attacked this particular one. Whether I am clear? So that's where we have a intermediate. It's a intermediate. So when it will be treated with moisture, when it's go for hydrolysis. So when it will go for hydrolysis, what do you expect? What do you expect?
Carboxylic acid.
Okay, no doubt. One is carboxylic acid. One is carboxylic acid and another one is MgOH. Okay, so that's where we have the reaction by using the Grignard reagent. Now if you observe, for example, I will specify the Grignard reagent. Okay, I have started with methyl magnesium halide. Which carboxylic acid do you expect? We are going to expect formic acid or ethanoic acid. How it's possible? We have started with methyl group, right? So that is the specialty of this method. Whenever we are using methyl group, the product will be ethanoic acid, not methanoic acid. So what I mean to tell you is, here the product will be this one because we are treating it with carbon dioxide. Okay? So if I am starting with the reaction with ethyl magnesium halide, then the product will be propanoic acid. Very good. The product will be propanoic acid. So what you can observe here? We can see that when we are going by using Grignard reagent, we are going to have one extra carbon. There is an increment in the number of carbon. It will not give exact alkyl, respective alkyl carboxylic acid. There will be one extra carbon will be there. So if I take methyl group, the product will be ethanoic acid. If I take ethyl group, the product will be propanoic acid. So that's what we can expect the reaction over here. Okay? Any doubts? Oh. Now you can expect the question in exam that explain or write the reaction for the conversion of methyl chloride. Write the reaction for the conversion of methyl chloride to ethanoic acid. Methyl chloride to ethanoic acid. How we can? You have to connect with the alkane stop. Question is simple. I want methyl chloride has to be converted into ethanoic acid. Oh, we have forgotten, sir. Nothing is there. Kashta is. So, methyl chloride has to be treated with magnesium, that's all. It has to be treated with magnesium. Then we are going to get the Grignard reagent. Then go for the reaction. We are going to get the Grignard reagent. We have to treat methyl chloride with the magnesium in the presence of ethers like solvent. Now what will happen? It is going to form the respective Grignard reagent. Then go for the reaction. That's how we can convert it into ethanoic acid, right? This can be one of the reaction. Earlier one, whether we can go with earlier one, Just 2 minutes back we had discussed now. Which is that one? That is by using nitrile. Whether it's possible?
It's not a, it does not recommend the spark.
I'm not getting, huh? You can see the notebook. You can tell me whether we can go with the earlier one also. We can go with earlier one also. Even by using nucleophilic substitution reaction, where if I treat with HCN, one carbon extra I am adding it, right, in the form of nitrile group. So this carbon I am adding one extra carbon in the form of nitrile group. Then also I am getting extra carbon only. Whether I am clear, whether people are understanding?
So could you repeat this part?
Oh, this one, right? See here, if I do this one, what I am going to get? I am going to get the molecule, this one, alkyl cyanide. But if you observe here, one carbon, second carbon. And this is the one which will get converted into CH3, COOH plus ammonium. If I go with acidic condition. So what is happening? One carbon is there, but in the product I am getting two carbons. So methyl chloride is getting converted into ethanoic acid. Clear? So what I mean to tell you is whether you go with Grignard reagent or whether you go with the nitrile molecule. In both the cases we are going to have one carbon extra when we are talking about the carboxylic acid as the product. This is how alkyl halide can be converted into the carboxylic acid compounds. Any doubts? Yeah. All of you are full silent, that's why I am asking. So shall we move to the next one if you don't have any doubts? So please remember, that's what repeatedly I will be telling. You cannot expect in organic chemistry all the reactions related to one topic. You should be in a condition to connect between the 2-3 topics with respect to the reactions. Even it will be helpful for your competitive exams. Okay? We will move to the next part. Now I will tell a molecule, acetic anhydride. Acetic anhydride. So somewhere we have discussed about this particular molecule, acetic anhydride. Yes, it is with respect to, especially if you go with Friedel-Crafts reaction. Yes, acetic anhydride. Right? So that's where I have CH3, CO, O, CO, CH3. Acetic anhydride. Right? So which can also be written as CH3, CO, twice O. Correct? Both are correct. In your textbook they might have represented like this. This is also fine. This is also fine. How we have got, why it should be called as acetic anhydride? Yes, very good. So 2-carboxylic acid which will be dehydrated to form the acetic anhydride. For example, I will take 2 molecules of acetic acid, okay, and another molecule of acetic acid. Now, if I provide the condition, they will be releasing the water molecule. They will release the water molecule. What is the form? Acetic anhydride. That's why it is called as anhydride. Anhydride means losing of the water. Due to that, that molecule has been formed. So that's where by losing of the water, this molecule has been formed. That's why it is called as acetic anhydride. Okay? So when I am getting a molecule, when 2-carboxylic acid, When they combine together, there will be liberation of water, and I can get the molecule. Whether I can take back the same molecule by adding the water to this, whether it's possible. When I am getting acetic anhydride by 2 acetic acid molecule by the liberation of water molecule, in that case whether I can get back the same molecule by adding the water, it is possible. Whatever I told first one, it was dehydration, where removal of water was happening from not from the same molecule to different molecule, where there was a removal of water. But here we are talking about adding of the water. We are talking of the adding of the water. That's where hydrolysis. We can call it as hydrolysis. We can call the process as hydrolysis. Fine? Because we are going to split the bond over here by using the splitting of the water molecule. Or by using the water molecule, we are going to split the bond. Therefore, it is called as hydro means water, lysis means splitting. Okay? So that's where this molecule will be giving rise to 2 molecules of acetic acid. Since I have taken acetic anhydride, I am going to get the 2 molecules of acetic acid. Okay? Say for example, H plus OH minus. If I take water, H plus OH minus. Oxygen is electronegative. Any one of these 2 leakage, it will be cleaved. So that means positive, negative. So positive part will go with the negative part. Negative part will go with the positive part. What we are going to get is CH3COOH. Then CH3COOH. That's what I have written. Okay? So that's where by using the water molecule, we are cleaving the bond either of this one or this one. Any one bond will be cleaved, and we are going to get the 2 carboxylic acids. Doubts idea? By seeing you people's face, I am getting confused now. Whether I have reached you people? Sir. After a long time, we are sitting in the classroom. As usual, you are bombarding us. What I mean to tell you is, first of all, if people are wearing the mask, I can't see the expression, but your eyes are like neutral. If I smile, my eyes will tell that story. I am smiling. If I am crying, then also my eyes will burn. But your eyes will be like this. So I am getting confused now, whether people are understanding or not. Okay? So that's where we have the preparation of carboxylic acid by using anhydrides. Which is that reaction? Hydrolysis. Same way, another molecule is there. We have another molecule which is called as esters. What do you mean by esters? RCO. Very good. So that's where RCO. Fine. So that's where we have the esters. Okay? So I don't think many of you have not attended the online classes, because all these things have been studied in earlier classes also. May not be related to this chapter or some other chapters, but it has been discussed. Right? So that's where we have the ester linkage. So therefore, any molecule which is having this particular linkage will be called as esters. Got my point? All of you have understood how these esters has been formed? Yes, by the reaction of carboxylic acid. Since I used RR, I will take that one only. Carboxylic acid and alcohol. Same as earlier. So there will be liberation of water. So there will be liberation of water. Okay, and due to that, there will be formation of a ester linkage. There will be formation of a ester linkage. But my point, if that is the case, whether I can get back the same molecule and I will go for addition of water to this. Anyway, you people have done with, I think, saponification. I don't know. Now it has not been, it is not there. But then we had one reaction, saponification, where ester bond will be cleaved. We are going to get the same molecule. As people are telling, we are going to get the same molecule. I will go for hydrolysis. Reaction, where by using the water molecule, I am going to split the ester linkage. We are going to split the ester linkage. So that's where I am going to get one molecule as carboxylic acid containing molecule, another molecule as alcohol, So however, what is happening here compared to earlier case? What is that difference? In case of acetic anhydride and in case of esters I am talking about. So in case of the anhydrides, we are getting 2 molecules of carboxylic acid. But here we are getting 1 molecule of carboxylic acid and 1 molecule of alcohol. That's where they differs from each other. What is the common feature in them? Both will be resulted due to hydrolysis. Got my point? So the same way we have another molecule. What is this? Acyl halide. He is telling acyl halide. Will you agree with that? Okay? Fine. So that's where we have the acyl halides, which can also be called as acid halides. Yes, it can also be called as acid halides. You will come to know why it can be called as acid halides. Now this molecule, even this molecule, can be converted into acids. That means carboxylic acid. How is possible? Wow. Yeah.
Basic condition.
Huh?
A basic condition.
Okay, basic condition. Is studying basic condition. Adding NaOH is telling. I am not telling anything. He is trying to give the answer. I am expecting from others also. Alva sir? Oh. I can see. She is a new girl. Alva? What about you? Okay. I can see 2 new faces. Yesterday only I observed. Okay, tell me fast. Simply we can go with hydrolysis. If you go with alkaline, okay, fine, it will enhance the reaction rate. But even you can go with simple hydrolysis. what product we are going to expect? And someone told water. That is carboxylic acid, no doubt. And another molecule can be HCl, but all of us we know HCl will be always in a dissociated form. Since it is a strong acid, always it will be dissociated form. So we can show it as Cl minus. Cl minus, same thing. Delta negative, delta positive, water, H plus, OH minus. OH minus will come here, H plus will go here. So that's why product will be actually HCl and carboxylic acid only. But since HCl will be always dissociated, we can show it as Cl minus. We can show it as Cl minus. Any doubts? So that's why we have the acid chloride. That's why it is called as acid chloride.
How do you get acid reverse? The one you just get fluorocarboxylic.
I'm not getting. No, how you can get chlorocarboxylic acid? No, it's not at all possible.
Yes.
Right? Because both are negative. It's not possible. Okay? So that's why they are called as acid chlorides. Okay, now? Any doubts? Because I think by this we are done with the preparation. I will go to it. Yeah, we are done with the preparation. So these are some of the reactions. Try to remember about the Grignards, preparation from Grignards and try to remember those reactions. Now we will come to the next one. In your in-text question, can anyone of you tell me? They are asking, show how each of the following compounds can be converted into benzoic acid. And the first one they have told, I am not going to write the reaction, just you should tell me the condition. So first one is ethyl benzene. How ethyl benzene can be converted into benzoic acid? Yes, that is by the alkaline KMnO4. Very good. Alkaline KMnO4. That's why ethyl benzene can be converted into benzoic acid. Then next question is acetophenone. Next question is acetophenone. Next question is acetophenone. Anyone? Just tell me the condition. Why Grignard reagent is required? What is acetophenone? Phenylethanol. Okay. ಕಷ್ಟ ಇದೆ. Anyone. You can try it out with this structure. Even in online, I don't know how many of you are here. They have asked any question, I don't know. Okay. So we can simply go with hydrolysis. We can simply go with the hydrolysis. Then we are going to get the product. We are going to get the product. Why go with Grignard reagent and all? Carbon, carbon.
It's carbon one, so how do you go to the hydrolysis?
Which carbon, carbon you are telling madam?
So how will I go with hydrolysis?
That's why people are not getting what is meant by acetophenol. So that's where, write down structure of acetophenol. Write the structure of acetophenol. That's why people are not getting the structure of acetophenol. Okay? Then I will stop here. Tomorrow we will solve this one, some more questions. Okay? So by tomorrow you should be get ready with acetophenol structure. Okay na? Okay? Fine. So thank you everyone. Tomorrow we are going to continue with the class. Tomorrow in the sense Monday. Okay na?